Hello everyone, we are at Beyond the Formula. Let's discuss why a capacitor opposes change in voltage. Right, so let's begin with a small question, interesting one. Say, can I change the voltage? Can I change a voltage across a capacitor? From say 0 volt to 10 volts instantly, right? So can I do that? Right, theoretically it seems like yes, we can do, correct, but physics says what? No, you cannot do that. Let's see, or let's find out why. Right, so we have a capacitor. Suppose this is the capacitor, and if I connect it across a battery of voltage V, and it has a capacitance of C, right? So what will happen? It will acquire some charge, plus Q and minus Q. We have already seen in the previous videos how this charge acquires, right? How this charge develops on the capacitor. Now you see, we have the equation here, right? The voltage equation is V equals what? Q over C, where Q is the charge on the capacitor plates and C is the capacitance of the capacitor, right? Now you see what controls the voltage. You see in the equation, you see here what controls the voltage. Voltage is nothing but voltage equals Q over C, where C is what? Capacitance, right? Now if I have a capacitor, its capacitance is fixed now, right? So we have capacitance as fixed value. Now only thing that voltage is dependent is on charge, right? If voltage changes, charge must change, right? If voltage changes implies charge must change, right? For a voltage to change, charge must change on the capacitor plates, right? The voltage exists because of separation, right? This charge, this separation of charge, this here, the separation, the voltage exists because there is a charge separation. If there is no charge separation, no voltage, right? If I connect these two plates, right, what will happen? The charge will disappear, and there is no voltage between the capacitor, correct? Now imagine suppose from 0 volt I change the voltage to 10 volts instantly. I changed the voltage from 0 volt to 10 volt. Now what should happen here? What must happen physically? A huge amount of charge must appear on the plates, right? Initially we have V equals to Q over C, and we have V equals 0, right? Which implies Q equals 0 coulombs, right? Now for V equals 10 volt, we should have Q over C ratio equals 10, which implies Q equals to 10 C coulombs, right? Where C is the capacitance. Now this amount, this 10 C charge should what? Should appear on the plates immediately or instantly, right? Now how the charge comes? How the charge will appear? Charge is nothing but current, right? We know that flow of charge is current. And how charge will appear? If there is a flow of current, we have I equals dq over dt, right? That is the current flow equation, right? Now this, what does this measures? This measures current how fast charge moves, right? So if you say the interval is large, so we have I equals delta q over delta t, Now for instant, for instantly changing charge, we have delta t approaching 0, right? So for delta t approaching 0 implies I approaching infinite, that is a circuit or a battery should supply infinite amount of current, right? Infinite amount of current. Now what happens? Nature cannot provide infinite current. Nature cannot provide infinite current. Hence what happens? Charge cannot change instantly. And if charge cannot change instantly, which will imply voltage cannot change instantly, correct? So this is all. Here we have an important analogy. Suppose consider this is a water tank, right? Water tank is capacitor, and the water inside it, has charge, right? Okay. And the level of water, is voltage. And suppose I am filling this water tank here, and what is this? This is nothing but current, right? Now to increase the level immediately, I should pour infinite amount through this, or a very large amount through the pipe, right? Correct or not? So you must pour water in at a high flow rate. Now high flow rate will imply in faster rise, that is infinite rise rate. Infinite flow is impossible here, correct? So already in our previous video we have saw that capacitor stores energy in its electric field, correct? Now to change voltage instantly, we would need to create that electric field very instantly, and that requires moving charge instantly, right? Moving charge very fast, and moving charge very fast requires infinite current, and infinite current cannot be given or provided. So hence what we can conclude is, a capacitor does not oppose voltage itself, What it does? It opposes sudden changes in voltage, right? Because sudden changes in voltage will require sudden changes in sudden changes in charges, and sudden changes in charges will require infinite amount of current that cannot be passed or supplied through any source, correct? Thanks.